equations into story problems using multiplication and division. And just to kind of recap this idea that when we're talking about multiplication and division, again, they are similar to addition and subtraction and that they are directly related. If I can do multiplication, I can absolutely do division. In this case, multiplication is this idea of taking groups and the amount in each group to equal a total. We call those two things factors, and they get us to our total on the end. With division, it's a little bit different. Our total gets moved over here to the end in this first part, and then we're dividing our total into groups, and that equals the amount in each. Keep in mind that I can always go about flip-flopping these two things here. I can go over and I can move these two things if I want to. They can switch places. I can also move these two. Notice the one thing in each of these equations that does not move. That's right, the total. The total always stays where it is. In multiplication, it's always going to be here. In division, it's always going to be at the very beginning. Okay, which is going to help us know a little bit as we're working. For here, we're going to group these two things together because they are related. It's really the question that is going to drive us in thinking about whether we're using multiplication or division. Here, there are lots of words that are gonna hint at or get us to think about multiplication or division. Here, when I see the word groups or see amount in each, those are going to be words that are going to tell us, hey, yeah, you're going to need to either do multiplication or division. Again, you'll want to be thinking at the end about what your question is to know precisely which operation you're using. Here, you might think of this idea that you have packs. Packs is another good one, or packages, right? Things that you might get from the store or from a large store where you get large packages that have a number in each. You might think that you got boxes. Boxes again hold more than one thing. Okay. Kits. You get a kit, it might have multiple things in it. Um, those would be words that would get us to think about that I have these larger groups and there's going to be a number in each. To go along with this idea of amount in each, another one that you might find that kind of works with this here, if I move this down a little bit so they're grouped together, um, per. This word per means having a certain number in each. Okay, it means in each. Um, and you sometimes will also see the word average, but we'll get more into that. This word average could mean that there's a certain amount that is been divvied out, but we'll get rid of that one for now. Just know that that can also come up. Those are going to be your most likely ones. We're not going to use the word total because again, we're going to see that in our question. Okay, so we're going to take here, for example, we'll take the same numbers for each of them because that's going to help us as we relate it both to multiplication and division. Here, let's say, for example, I've got 8 times 8, or no, 8 times 5, okay, equals x. Again, x meaning my variable, the thing that I am solving for. If you felt like you wanted to put a question mark here, that's fine, but we're going to start transitioning to using a letter to stand for that question mark. So here I've got 8 times 5. What that reads as underneath here is if I'm really thinking about it, it says it's 8 groups with 5 in each equals x total. So that's going to help me quite a bit as I move forward thinking about what my question could be. Underneath here, I'm going to want to think about groups and things that come in groups. So maybe, another good one over here that I forgot to put in here with groups could be teams, tables, like table groups, rooms, classes. So lots of things that have multiple things in them. So in this case, I'm thinking of 5, and I think of basketball teams. Basketball teams have 5 players. There are 8 teams of that, or 8 basketball teams. Okay. So already here, I know that this is my groups. After that, I go, there are 5 on each team. Now I got to think about what my question is. My question for multiplication is going to look for a total. And when I think about my total, I have 2 different things. There are 5, and I should have said this here, there are 5 players on each team. So here, if I really were to draw my 8, this is team 1, team 2, team 3, team 4, team 5, team 6, team 7, and team 8. Okay. I've got 5 on each, right? We go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I could do this for all of them. As I think about it, I go, what am I counting up? Am I counting up the dots? And what do the dots then represent? The dots in this case represent players. Okay, that's going to go into my question. How many players are there? I could also use the word total. Okay, there in total. That would totally works. I could take the same exact numbers here, and instead, if I look at this, I know that this here is 8 times 5 equals 40. So I can now go from this to 40 divided by 8 equals x. So here, let's do that for our division down below and see how that changes as we're working. So here, if I look at this here, 40 divided by 8 equals x. Okay. So for division here, I'm going to start with my total. There are 40. I'm going to think about what that 40 is. It's a total of what? Again, just like up here, am I looking at teams or am I looking at players? Here again, because it's my players, right? I'm going here. There are 40 players playing basketball. There, there are 8 basketball teams. My question then is, if I'm taking my 40, again, if I could do this here, 2, 3, 4, 5, 6, 7, 8. We keep going here until I've got all of them here. Gotta do 5 groups of them. Again, this is why, particularly when we're in here, we don't necessarily always want to do dots because the dots, while we're doing this, could take a while for us to draw. So if I've got this here and go, all right, so what am I going to do? I'm going to put them into 8 teams, right? And I could go on here, how many are on? I represent that with my problem over here. We go, okay, so 1, 2, 3, 4, 5. So we got this here. Here, in this case, I got to think a little bit. If I've got 8 teams, oh, I got to undo what I did there twice. I got 8 teams, 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be here. So it's one factor. It's here. I'm going to put 8 on this team, 8 here. And again, I know in here that this here means that I took it and I've got 8 with 5 here. So I've got 8, I've got 5, that's my other factor. And because of that, I know that here in this case, x equals 5. You want to be thinking about what your equation is, what your context is going to be, whether you're going to use classes or rooms, tables, groups, teams, packages, and then try your hand at turning that equation into a story or word problem.